All right, so homework. Any of those that you'd like me to go over are the 7, 8, or 10? So just like the warm up, right? Going over that warm up, hopefully. Help if you're messing with that. Looking at my pictures, you guys okay? My graphs? All right, and then the matching was pretty easy because all I did was figure out the vertex. What's this vertex? 3, 1, right? So I just found where the 3, 1 was. So here it is, 3, 1. So that was C. Just did that. That's all I did was found the vertex and then looked at the picture. And then I could match it. Okay? We're good? Hopefully? All right. So today got kind of a lot of notes. So, follow along. But if you got questions, make sure you ask. Okay? And some of this is review because we did some quadratic review before we even started the book. All right? So those problems we just got done doing were in vertex form, right? So this form we call here we call standard form. And that's what we had said back when we were doing some review. When we had that little review quiz. All right. So all this is saying, when A is positive, it does what? Opens up. And when A is negative, it opens down, right? Oh, just saying it right there. Okay. To find the axis of symmetry, we use this formula. And we had used that on before, right? That's something we've learned already, right? So just reviewing that with you. Once we found what the axis of symmetry was, we substituted whatever that answer was into the function for x. Okay, so now whatever we got for x, for the axis of symmetry, was the x value of the vertex, and then we substitute that number in f of x, which means putting it in place of x into the function to find the y value. Okay? And the y-intercept is the c value. So the y-intercept is always 0, c. Okay, and that's what they're putting here. There's the y-intercept for that one at 0c. Here's the y-intercept for this one, 0c, whatever the c value is. So this stuff should be reviewed for you guys because we worked on this. We did a little linear review, we did a little quadratic review before we got into the book. Okay, so let's go ahead and look at something here, an example. So it says graph that function, label the vertex and axis of symmetry. All right, so to graph it, we need to figure those out first. Okay, so I always like to find the axis of symmetry when it's in standard form first, using our formula. X equals negative b over 2 times a. All right, so negative, what's my b value? Negative 6 over 2 times what's my a value? 3. We all remember what A, B, and C is, right? If that helps you to write it down on the side or under the problem, wherever you're doing it, go ahead. If you don't need to, you don't have to worry about it. So what happens to the 6 up top? Becomes positive 6. What's 2 times 3? 6. What's 6 divided by 6? 1. So there's my axis of symmetry. All right? So since I have to graph it, I'm going to go ahead and put it in there. Okay? Oops, there it is. All right? So then I can do the vertex. What's the x value of the vertex? 1. Okay? Where do I find the y value? Plug it in, right? So I got 3. So for the y, I got 3 times 1 squared minus 6 times 1 plus 1. What's 1 squared? 1 times 3, 3. What's negative 6 times 1? Negative 6 plus 1. So 3 minus 6 is negative 3 plus 1 is negative 2. So there's our vertex. Is my A positive or negative? Positive. So which way is it going to open? Up. What I would do and what we did before, since I know C is 0, I know the what? I'm sorry, C is 1, I know the what? What is C? The y-intercept, right? So I already have a point right there. So what can I do to find the other one? Mirror it, reflect it, right? So this one. Do I have enough to write or draw my parabola? Yeah, got enough. Starting to come back a little bit? Okay. So this is basically a review of stuff that we did for a little bit before we got into our book earlier in the 9 weeks. Questions? Con, I forgot that you wanted to do that. Sorry. If you want to go into the hall too, you can. If you're okay where you're at, that's fine with me too. All right. All right, max min. We talked about this before too, right? Because the vertex is the highest or lowest point on a parabola, its y-coordinate. Remember, y-coordinate is the maximum value or the minimum value. Y-coordinate of the vertex, right? Because the vertex is the lowest point or the highest point. Okay? The vertex lies on the axis of symmetry, so the function is increasing on one side of the axis of symmetry and decreasing on the other side. Okay? Increasing means it's going up, and decreasing means it's going down, right? That makes sense? All right. So it says find the minimum value or maximum value of that function, find the domain and range of the function, and when the function is increasing and decreasing, okay? It doesn't say we have to graph it, right? But we got to find the min or maximum value. So we have to find the what? The vertex. Okay, in order to find the vertex, when it's in standard form, we got to figure out the axis of symmetry. So we got to find those out anyway, even though we don't have to graph it. Okay? So, first of all, let's write this down. What's A equal? 1/2. So, does it open up or down? Up, because it's a positive number, right? So, does that mean we have a min or a max? A min. Right, Jordan?
Yeah.
All right, so just looking at the A value lets me know if it opens up or down, if it's a min or a max. Questions? Okay. Now to find and then let's just do B and C. What's B? -2, C, -1. All right. So to find my axis of symmetry, remember we're going to use this formula, right? So B was what? 2. A was 1/2. What happens to the 2? Positive. What's 2 times 1/2? What's 2 divided by 1? 2. All right? So I figured that out so I could figure out the what? The y value, because I want to figure out the vertex. Right. You guys are so smart. Good job. So we're looking for the y value. How do I do that? Plug it in to the function, right? So it's 1/2 and then 2 for x squared minus 2 times 2 minus 1. All right. What's 2 squared? 4. What's half of 4? 2. What's a -2 times 2? -4. What's 2 minus 4? -2 minus 1? -3. Okay? So, find the min or maximum value. So what's our minimum value? -3. It's just the y value of the vertex. Okay? What's our domain? Right. All the parabolas we've talked about have opened up or down. Okay? So when it's a parabola that opens up or down, the domain is always all real numbers. That's our fancy R for real numbers. Now range is which values? Domains are x values, ranges are y values, right? Now, since it's a minimum, do I put greater than or equal to or less than or equal to? Greater than or equal to. And what value do we use for the range? That -3, that min value. You guys remember that? On the quiz we had on that, sometimes you guys would put the x value for that. Okay, it's the y value for that, remember, because that's what range represents, the y values, right? We also have to do increasing and decreasing. Okay, so what kind of parabola, up or down? Up. All right, so if I have if I do a little, 2 -3 is going to be down here somewhere, right? All right, so from, here's our vertex. On the left side of the parabola, what's happening? When I drew it, I guess it's going, we always put the arrows like this, right? But it's actually, we always think of it left to right, okay, when we look at it. So left to right is going down or decreasing. All right, so it's decreasing. Let's do it in purple. when y is less than, x, we want to do the x value. When x is less than what? 2. And then after it gets to 2, it starts doing what? Going up, right? When x is greater than 2. Okay? So we did have to graph it, but if it helps you to graph it, go right ahead. Questions? All right, so the A value tells us if it opens up or down, then we know it's a min or a max, right? Axis of symmetry helps us find the vertex so we can figure out that min or max value. Domain for these parabolas right now, they're always opening up or down, is all real numbers or x values. And range is, if it's a minimum, y is greater than or equal to the minimum value. If it's a max, it's y is less than or equal to the minimum. Then decreasing and increasing. If it opens up, the left side of the parabola is decreasing, the right side is increasing. If it opens down, the left side is decreasing. No, the left side is increasing, left to right, and then the right side is decreasing if it opens down. And you just use the x value as you're going left to right, the horizontal. Questions? Okay, kind of a lot of stuff there, but we had done a little algebra review stuff earlier this year, which I hope has helped you. All right, one other way for graphing using x-intercepts. Remember, x-intercepts is where the graph crosses the x-axis, right? So they call this intercept form here. We still got our a value, and then x minus p and x minus q. It's what we call factored form. Okay? So intercept form is when our standard form gets factored. And we'll do some factoring here eventually, these quadratics. Okay? The axis of symmetry, once you find these 2 points, these 2 x-intercepts, it's always halfway between them, right? So the way they found half is whatever the p value plus the q value divided by 2. They just took the average, right? So you can do that. All right? Most of these parabolas will have 2 x-intercepts. Every now and then, the vertex will lie on the x-axis. You only have 1 x-intercept. Sometimes your parabola will be above the x-axis, then it won't have any x-intercept. So that could happen. All right? But still, when A is positive, it opens up. When A is negative, it opens down. Same rules. Okay? The y value is always 0 on the x-axis. Okay? So it's in factored form for you. It's in x-intercept form. Right? That's what we called it. Just intercept form, I guess they call it. All right? So label the intercepts, vertex, and axis of symmetry. All right? So my x plus 3 and my x minus 1. All right? To find my x-intercepts, I got to set them equal to 0, right? So we're thinking, remember, we can rewrite this as y equals instead of f of x, right? So if y is 0, this is my equation I'm trying to solve. Well, if I'm multiplying 2 things and the answer is 0, what must be true about at least one of those 2 things? It's got to be 0, right? Make sense? If I'm multiplying 2 numbers, the answer is 0, one of the numbers has to be 0, right? So what we do is we just think about it like this. Most of you are going to get to the point where you can look at the 2 factors and tell me what the answers are. Okay? It's just going to be the opposite, right? What am I going to do to move the 3 over? Subtract. So one of my x-intercepts is right there. Okay? This one we'd add 1, right? So my other x-intercept is here. All right? Basically, we know that our parabolas are symmetrical, right? We have an axis of symmetry. It cuts your parabola in half, so it's got to go halfway between those, right? Or, what is negative 3 plus 1? And what's negative 2 divided by 2? Negative 1. Is that right down the middle between those 2 points? Yeah. So, you guys can figure out where halfway between those 2 points are, right? Mathematically, you can just add the 2 numbers and divide by 2, or looking at the graph, you can do it. Does that make sense? So, I found the x-intercepts. Go back to the pen, right? Found the x-intercepts. We found the axis of symmetry. We've got to find the vertex, right? Does this open up or down? It's going to be down, right? Okay? Because my A is negative 2, right? So any ideas on how I can find that vertex? How did we find it before? Nolan? What did we do on the last problem? How did we find the vertex? What did we find first? Axis of symmetry. What did we use? The 2, right? So it did what with it to find the y part? Plugged it in. Can't we do the same thing here? We know that the axis of symmetry is x equals negative 1. Can't I plug negative 1 into the original problem? Won't that give me the vertex? Yeah, same procedure. So that's nothing new. Okay? So we'll go negative 2, and then negative 1 plus 3, and negative 1 minus 1. We're putting negative 1, our x value, our axis of symmetry number, into the function. So what's negative 1 plus 3? 2. What's negative 1 minus 1? Negative 2. So what's negative 2 times 2? Negative 4. What's negative 4 times negative 2? Positive 8, right? So up here at 8 is my vertex. Negative 1, 8. And then there's my graph. If I asked you, where's it increasing? Going left to right, it's this one. So it would be when x is less than negative 1, right? Decreasing is when x is greater than negative 1, if we had to answer that. Is this a min or a max value? Max. What would that max value be? 8. What's the domain? All real numbers. What's the range? Y is less or greater. You guys are good. Right, Landry? Look good, feel good? We haven't done that for a while. We got to practice again. When I say look good, feel good, you're supposed to say you are good. I don't know. Right? Let's try it. Tristan, you got to participate. Look good, feel good? You are good. You guys did a very good job today. There's your assignment. Yes, sir. Yeah. If you want graph paper, I have some up here if you need it. Just pull it off my desk up here on the front corner.